So first off, for this session, we're going to talk about migration from on-prem messaging service system to the cloud. We're going to talk about what, how, and why. This will be more like an introduction level of the session where we talk about messaging systems migrations. So if you already have done numerous migrations before, well know about migration for messaging systems of your organizations, feel free to skip this session or go to the other sessions. That's fine with me. So for this agenda, we're going to talk about messaging system overview, the stages for you to migrate, and what are the benefits for you to go through all the hurdles of you to migrate from your on-prem all the way to the cloud, and also as well as a strategy to move, give you at the end, leave you some key questions or some key factors to consider with your team. If your team decide to migrate to the cloud, what are the things you want to notice of? All right. So in terms of messaging systems, there are as of today's world, there are actually two types of categories. One is called cloud native, where it's like, for example, in Amazon, we have SNS and SQS. Those are like built in for the service that are directly serverless, that you can send the message in and put the message out from the other side using API calls. So those are called cloud native services. And the other is called like traditional applications, which is majority of the customer we are seeing us use. That, for example, those are called like messaging-oriented middlewares or like message brokers. For example, classic example will be IBM queues, RabbitMQs, or ActiveMQs. And by the way, as a background for me, I work for Amazon Web Services as a cloud support engineer. So most of the time I do work here is where like customers, when they see something not working, particularly for example, like messaging systems going down, like where the last session where we talk about SiriusXM, like for example, the platform, if going down will be like millions of dollars impacted, they come to us and to try to troubleshoot with us. It's more like a reactive approach, but when we want to talk about like how we can prevent them at the first place, we learned a lot of lessons from there. Particularly when customers are migrating from the on-prem to the cloud, we see there are not only sometimes you are some of the catches that they might fall into, the pitfalls, or sometimes they might need to change some of the mindset. So that's where we learn from there. And that's why when you want to move from traditional application to the cloud, there are also some things you have to be aware of. So this is what our session is about. Now, back to the message system application. There are some different industries have different use cases. So, for example, like for financial services, you want to purchase for trades or like transactions. For retail, you have ordering systems. And also for healthcare, you have to put patient data records. Each of them have like unique challenges for them. Like for example, for financial service, you usually have like high volumes or like requires of low latencies. Usually a relatively high level of uptime requirements for this. And in terms of retail, like you might have a spiky workloads compared to, for example, on the first hour of business, you might have a much higher workload than like any other hours that you have per the day. And for example, on the evenings, you probably don't have anything to run with. And for healthcare, you have extremely stringent requirement of your uptime. Even during like your system on the maintenance, you do have your customer demanding you to be available, right? You don't want to have any time where your patient or your EMS system are getting down. But all in all of these industries are able to successfully migrate or use a messaging system both on the cloud and on-prem, as we see numerous examples before. What the messaging system really offers for them is I have a loosely decoupled systems where you have like consumers and producers really separated out, and you can build much larger scale systems around. And also because of this, you have a much more fault tolerance. So think about it, for example, your consumers are getting down. The worst case scenario is not that your entire system is crashed. It's that maybe there are a few massive backlogs in your systems, but that's it. Once you recover, you'll be able to easily catch up. So that's the benefits of you having message systems in your solutions. Now, when we see to migrate from the on-prem to the cloud, usually we have a few of the strategies to go with. So as a startup, a lot of the customers especially for small teams, to start with the on-prems. Like it's quite easy to set up a server or something, or a minuscule like on computer to do that. What we see for the on-prem messaging brokers is that it's quite expensive to run this. I start with like when you scale up, you have to purchase for capacities, you have to have a huge investment on the front, and also you have the operational overhead. Like you have to have like dedicated engineers to monitor the system, to set up the infrastructure to make sure that it works in well with your own on-prem environment, and you also have to make sure that it has good observabilities, that you have to be able to know like whether the application is running fine, whether we need to upscale further further or downscale that, etc. So it's really not sustainable if you're continues to grow up on that way. So what we see from the customer side is that we see they are having different ways of strategies to move to the cloud. And sometimes they're like more like a pipeline where they go from the easiest one approach with a lift and shift. It is, for example, just a purchase for a cloud instances like a EC2, and then moving from that approach, they might go instead to go like Replatform, which is like moving to more like a managed services or like a platform service like AWS. We have Amazon MQs, and then we eventually like they will be more involved like refactoring themselves to be fully serverless. We will discuss about rehost, replatform, and refactors in the next few slides to talk about what the differences are there and what are the pros and cons for them. So as we mentioned about the migration journeys, we see that the responsibility also slightly changes. And that's essentially more like a business model or mindset also changes. And one of the benefits for you to when you want to migrate to the cloud. I start with on the on-premises, you have to worry about everything on your own. So from security, physical security of the servers to the reliability of your hardware infrastructures, to all the security setup, to the environment, as well as your infrastructure's configurations, as well as applications. That's everything you have to set up on premises. But when you go to the infrastructure or service, let's for example like EC2 or something, the physical layers you are off, like it's not your responsibility, but more in the cloud service providers. And then the security is more like a shared responsibility model. We, as a cost provider, we do manage for the security of the instances. We do measure to make sure, like for example, if your instance turning down, that the data won't be recovered, that everything will be like encrypted, and everything on the basic network connection will always be there. But in terms of the security as a configuration, for example, if you still don't want to open the port to the entire world, so that it will still pose as a security risk for your entire system. So that's why it's more like a security shared responsibility model from there. Now, when you move to the managed services like Amazon MQs, you will even further reduce some of the responsibility on your team, which is a good thing for your team in terms of a technical standpoint. Where, for example, like the software installations, for example, like the application of your brokers or the infrastructure configurations are all followed or managed by the platform service itself. You do not have to worry about them on your own. And if we have to configure, follow the best practice of the open source community, for example, so that you are always getting the best practice follow up from that perspective. Now, eventually, some of the customers decide to go fully cloud native, which is serverless. And in that case, your discussion will truly rule out of the capacity concerns. So in that perspective, like before that, maybe in the managed services or infrastructure service, you still have to think about how many CPUs I want, how many RAMs I want. But in terms of serverless, you do not really need to really care about capacities. And all you need to care about is your business logic, how you can optimize this, how you can reduce the amount of transactions needed to send in and out of the services to help you further optimize your service itself. So your own, like the majority of your time are spending working on the business logic itself rather than spending overhead on like management or infrastructure levels. Now, as earlier, like a brief hint about this, one of the benefits is to decouple your infrastructure discussion from your solutions. So you do not have to worry about those like the provisioning, the selling up, or something like this, like what happens if maybe next Monday I have 3 amount of workloads than last week before. So that's one of the benefits for serverless. That's a lot of people want to do that. And also another thing is pay as you go or pay for what you use. So that means like you don't have, for example, like back to the On-Prem processing service for retail industries. Like for example, in the evenings, you only have very sparsely requests. And in terms of like you go to managed services or EC2s, you still have to set them up. There might be like sparsely 1 or 2 customers coming in or checking out, but you still have to have the entire system setting up, which is really a waste. But in terms of serverless, it doesn't matter. We scale up and down automatically as totally transparent for your applications. So that's one thing that is really helpful for your team as well. Like you manage it for your cost and optimize for that one. And also it's highly available and like doable by the design of the service. So when we design the service as like a service architectures, we design it in such a way that it will be multi-AZ, which means it will deploy in multi data centers. Your message will be copied into multi data centers. So in case one data center gets like crash, or for example, some service doesn't work, it will automatically reroute your request to the other one. So it will be highly available and durable without anything you change yourself. As long as you are adapt into the service, everything goes just fine. So let's talk about the first strategy. a rehost, which is live and shift, which is very simple approach that one of the most benefits we get is that it's very highly customizable. Like you can customize from the very low level, like OS level you want to choose, what are the frame size, what are the buffer, what are the network package size you want to determine for that, what type of version of the RabbitMQ or ActiveMQ you want to deploy on this. Everything is fully customizable, it's quick and easy, and it requires minimal changes from your on-prem application to the cloud. It's very quick to get started, but on the same time, with the same side of the effect is that you will still have like manage for the infrastructure, because everything above the infrastructure level is still like a black box for the cloud service providers. So because of that, you will see that it's not really have any built-in like monitoring for your applications. You still have to find a way to populate a matrix to tell like whether your applications running fine, whether application getting any errors, any signs of errors before that. Things like the monitorings are still built on by your teams. And also there are like integrating with other services are not that easy. It's doable, but it's a little bit more comprehensive than that, because for the, as already mentioned, like your application level are still like a black box. So for example, the benefit of using IAMs, you're using like other services like organizations to help you to migrate your user base to the cloud are still like based on your own team's designs. So that's one thing that you have to consider for this. And then that's because of this, some of the customers decide to go to the replatform, which brings us a couple more advantages for this. Let's pick up MQ for RabbitMQ as an examples. Because we see a lot of people using RabbitMQs even in their on-prems, and when they change that, they see RabbitMQs as an offerings, they tend to select for MQ as a service. Because it is more like a managed services, what we do here is like when you set up, you do not necessarily need to set up like the configuration with the low level, like the OS to manage for the like the packet, the frame size or the watermark levels. It all follows on the open source community best practices. What you do need to consider is like the deployment, like the single node deployment or the cluster deployment, so that which we'll talk about later about to use what, but it's more like a much simpler selections on your side. It's much easier to set up compared to EC2 or your on-prem, you have numerous configurations you have to go through. Also, the scalings compared to rehosting, like you have to change from, let's say, from 2 core CPU to 4 core CPU, you have to reset up the entire EC2. Hopefully, you have some configuration saved and to copy there. You have to worry about how to migrate the message from the original EC2 to the other one. For scaling for MQ, it's quite easy. You change the configuration, reboot the broker, that's it. We have the configuration for you, we save this, and we migrate all the messages for you on that end. So everything is very easy to set up with. Also, security is already follows the best practices. So everything, so it's already like TLS enabled. So the connection is already enforced by the encryptions. Also, you can have the customized KM keys to make sure that your encryption is at rest. For upgrade and maintenance, it's also managed by ourselves. So like you will always have the latest versions. You don't have to manually upgrade or patching up your like the broker or OS levels. It's automatically managed by us. So like you will reduce some of the operational overheads by that means. So in terms of deeper loops, it will follow the same protocol support as a RabbitMQ, like the AMQP 0.9.1, but you have the option of the single node or the cluster node, which will come up to the next slides. But in terms of that, you will have, because it's already pre-installed as an application that we offer as a service, you have the management plugin which powers the RabbitMQ web consoles. You script like RabbitMQ admin. You can use that for monitoring, as well as like you can monitor through the like CloudWatch matrix and logs to have automatically built in that you can use to see like maybe some error logs are populating, or maybe like how much CPU you are using, how much RAM you're using, how much message are sending in and sending out to understand your workload better. And also like shovel and federation to move message around of the broker. So already like the plugins are well utilized by the open source communities. We have ported them into our service as well, so that it helps, like also helps with migration if you want to go to on-prem to the cloud. Now, in terms of the single node and cluster deployment, for single node, as the name suggests, it's one single instance broker deployed in a single AZ. It's not really it's really recommended for production because of the availability. Think about this way. Let's say the node crash, or that AZ temporarily gets like network disruptions, you will lose access to the broker for a set period of time, and it will only get back when it's recovered. Or for example, it's rebooted, you have to wait for that 25 to 30 minutes for it to get back with. But on the opposite side, it has a slightly marginal benefit of a lower latency, because you do not have like cross-AZ communications for the sync up of the messages. So it's a slightly better, but overall we would not recommend it for production because the availability disadvantage overweigh for your latency benefit from this. Now, in terms of cluster deployment, we have 3 nodes. So what that get is much higher availabilities. You have 3 nodes deployed on each of the AZs. And then when you send a message in, it automatically mirrors to the 2 other nodes on the 2 other AZs. So let's say, for example, one of them will get crashed, one of them will get replaced. What we see here is the 2 other nodes also have the same messages. You consumer or producer, as long as they can able to reconnect, they will reroute the traffic to the 2 other available nodes to still get the message there. So you will almost get always uptime for the workers, as long as your consumers and producers are able to retry the connections. And additionally, because if, like, for example, during the reboot of the cluster or during the maintenance, the nodes are getting down one at a time. So it's not going down the full cluster, it's unavailable. When one node get down, the 2 other nodes service the traffics. And then when that node already finish up the patchings, it comes back, the second node goes down. And then that first node was serving the traffic from node 2 and then continues forward for the node 3 as well. So it will be like much higher availability. That's why we recommend for production usage. And in terms of moving messages, we have federation and shoveling. So those are the 2 plugins that we see commonly using, and also we have them built in already. Which what federation means is, think about this. For example, like you are trying to migrate from the on-prem to the cloud. You have federated. You can build a federated queues and federated exchanges. Let's talk about the second one first. Federation exchange. Federation exchange means that you have an exchange that kind of like coexisting on both sides, where you send a message in, it copies to both the on-prem and the cloud instances of the workers, so that it can route to the queues, no matter whether the queues exist on your on-prem environment or your cloud environment, so that you can making sure that your exchange can function as expected, just as a whole thing. You don't have to worry about whether that is deployed on the on-prem or is on the cloud. Now, for the federated queues, it works similarly, but on a different way, in the sense that when the consumer takes a message, if let's say you have 40% of consumers still on the on-prem, 60% on the cloud, when one of the consumer on the on-prem takes the message away, the consumers on the cloud will not be able to see the messages. So you will reduce your chance, it will eliminate your chances of you to duplicate your process workload, but still allow you to have the gradual migration process along the way, powered by the federation queues. And then in terms of shoveling, it's much more simpler approach. Shoveling is more like a well-built client that are like moving messages as a consumer from one place to another. Because of this approach, it allows you to deploy anywhere from the source broker, destination broker, or even the third places as an individual source to move the message around. What really helpful is that it can help, like, for example, if you have like millions of messages in your on-prem broker, you try to move that around periodically to the on-prem to continue processing there, you can do that as well. So it's like easier, simple approach, but it also offers you much more flexibility in terms of where you can deploy the shovelings. So now once you go to the migration, once you go through the migrations to the replatformings, some of the customers will say, hey, how can I do better with that? So one of the things, as I earlier mentioned, is go to full serverless, which requires you to refactor, which is much more involved process. So first off, you have to want to think about decoupling of your producer and consumers. Why? Because let's think about the messaging backlog examples. When you have backlogs, you want to scale up your consumers without any changes on the producer. You don't want to scale up the producer at the same time, because if you scale up, it doesn't help with the backlogs. So that's one thing you want to change, is try to decouple them so that it can scale up, update independently. That's one thing you want to think about. And then the next thing you want to think about is, what is your message infrastructure? Are you going to a queue-based, which is point-to-point, a producer send a message in, a consumer evenly distribute the message and process it only once, or is sending a message to your system and then all the consumers have to process on the same copy of the message? That's more like a publish subscribe model. Unfortunately, when you do a replatform, or you move to the MQ, or you are using MQ, you can do that both. Like for active MQs, you have queues and topics, and for RabbitMQ, you have queues and exchanges. Those are functioning like the queues and topics are architectures. But in terms of serverless, what you have is SQS for the queue-based architecture, and then for topics, you have SNS, which is similar like a fan-out version, which is more focused on the publish and subscribe models. In terms of protocol support, this is also one thing you have to consider about when you do the refactors. So One thing about serverless migration is that because it is serverless, it's more like based on it, like when you move, as earlier mentioned here, if you can think about it as each individual queue and each individual topic, you don't have to migrate all at one time. You can migrate a subset of your queue, subset of a topic in your systems to the serverless as a pilot to see whether your application can work that way. And then during refactoring, you want to think about the protocol support. So for example, originally you might have a long-lived connection through MQP, WebSocket, OpenWire, etc. And then for the serverless, what we have on the cloud is more like a REST API based. It's more like an HTTPS or JMS application, which is much short-lived. So that's one thing you have to change. But fortunately, we have like SDKs and APIs for support that, so you don't have to write your own HTTPS based on that. And also, you have to think about the order considerations. So for MQs, by default, it's more like a first in, first out orders. But for like when you move to the serverless, it can be like you have the option to determine whether it's a more like a standard various like best effort basis ordering or a strictly first in first out. And even for a strictly first in first out queues, you can also think about how to increase the concurrencies based on, for example, like message groups. Think about, for example, order processing systems where you can have like customer IDs as like you only need to take the order sequence for each of the customers, but for across the customer, it doesn't have to necessarily be the first customer have to come first or the second comes after. You might have to be able to concurrently process the customer orders concurrently. In that case, you might have to use message groups IDs to the customer IDs so that you can have increased concurrencies that way. And also for when you go to the serverless, it's the black box area is much more like minimized. So you have CloudWatch and CloudTrail logs so that can have like request level logging. It will really helpful for you to understand like what are requests are sending in, what are the IAM roles, what are users are sending in, what is the IP address, how many messages are sending in, sending out, what are action are taken at what time. It's much more detailed analysis, detailed observations for your team to do troubleshooting, analysis, auditings. And also because it's already building as a full services, it has a much simpler way to native integrate with, for example, like authentication, authorization, like IAMs, identity centers. So you do not have to build in like a LDAP server or like Active Directories to integrate with their MQs. It's much more simpler than that. It's much more native because we already have those like authentication, authorization, like protocols or services already in use on the service itself. And also for the efficiencies, let's say we have like your team is using like short-lived like request response patterns, which is like much more short-lived queues. You don't have to declare the physical queues on your account, which will result in millions of queues on your account. You can use, for example, temporary queues with more like logical queues that are like shared across one of the single physical queues, so that it's more like a naming convention rather than an actual physical queues that helps you to work around those like request response patterns. As well as, for example, let's say your message maybe go over 1 megabytes, which is the limit of the message size. What we have like for the Java and Python SDKs, we have the large payload support, which allows you to utilize instead of sending the message directly. Yes. So instead of sending it directly to the like the SNS or SQL service, you can send it to the S3, and then the pointer will be like a link sending in as a message. So it's much more smaller size, and then allow your consumer to take the pointer, go to the S3 to get the object. And in that, those are all like transparent on your application. You don't have to worry about that. The application itself of the Java SDKs or the Python SDKs made by AWS already have that wrapper around. So those are refactoring considerations you have to think about. But no matter what of the migration strategies you work with, you have to think about the nuance of each services. What are service limits? Like even outside of AWS, you go to Google or Azure Cloud, you want to think about what are nuance of each technology, whether it's like what are limitations, what are benefits to gain from there, what are support you have. And then you have to think about authentication and authorizations, because when you're on-prem, it's much easier to do user pools to identity management. But you have to also follow up to have the same like the permission management, authentication, authorizations on the cloud. So how do you do that? So you have to think about that as well. Also, before you go to production, you want to do a full good performance testing to understand like whether I'm over provisioning my like server-based architecture like an MQ or like, for example, in terms of service, whether my model of my throughput, my requests are really cost beneficial for us to do that. It's like performance testing. As well as for deployment, because when you go to the managed service or like a service architecture, the level of changes or level of the customization you get is much more smaller compared to you do as an on-prem or like EC2. So like you have to think about that as well, like how you want to do the deployment. For service, you are deploying each individual queues and topics. Are you able to ready to handle for that? And also in terms of my side, when you do the troubleshooting for the on-prem, you can maybe do like very low-level troubleshooting, like packet capture on the server side. You can connect to the server to see what's going on, what's going wrong with the errors, what the debug level of these are. But in terms of like, when you go to the cloud, some of the troubleshooting applications that you have might not be available. You cannot do the packet capture on the cloud, right? So in that case, you have to more heavy use on metrics, more heavy use on loggings, and also combined with the application side of logs to understand the whole picture of what happened at that time. So that's more like a mindset changes of your team to know how to troubleshoot, how to monitor, and how to observe in case of errors occurs. So in summary, migrating the message system to the cloud allows you to have a much higher availability and a much higher resiliencies compared to you have to do this on your own as an on-prem. And also there are multiple stages for migration. You can go like rehost, replatform, and refactoring, which is much more involved. But overall, no matter what stages you go, a successful migration requires you to have not only the application level changes, but also the mindset changes of yourself to think about like how I manage for the business, how I manage for the troubleshooting strategies, how I manage for my team to deploy this to maintain its sustainability. So that's it for my introduction. Thank you very much.